A very warm welcome to this short demonstration of one aspect of the ESCAPE OSSR, the open source scientific software and service repository, how integrating software under the FAIR paradigm furthers open science. Let me introduce to you two use cases of the OSSR. The first use case is in the regime of astroparticle physics, a combined dark matter search with gamma rays. In this article, the software G-like is used to calculate sensitivities of different gamma ray experiments on dark matter particles of various masses. We can find the software on the OSSR landing page, which leads us to the Zenodo community of ESCAPE 2020. And here we can find the software. Here you see the entry of the software and you see that it's available as source code on GitHub, but also on OpenAir to find it, and you can find a stable release of that software to work further with. Now I downloaded the software to my computer, as you can see it here, and wrote a script to build and execute the software as detailed in the README. The process will run in a Docker environment provided by the root project, so let's start it. I already pre-compiled the software, so the build process is fast and the tutorial program starts almost immediately. It will run some minutes, so we will do a fast forward from here now. The likelihoods have been calculated now for generic experiments, and we can have a look at the results, limits and sensitivities using the root software. In summary, we were able to find G-like via OSSR, but also via OpenAir. We were able to access it both in an archive and a development platform. We can interoperate, for example, with our own root-based software, and we can reuse it, not only reproducing the results of the article, but building our own analysis on it. Let's get back to the OSSR now and take the interoperability and reproducibility even a step further. For this, we take a step over to radio astronomy and the SKA project that published a data challenge in 2018 to prepare the community for what to expect from the experiment in the future. As this challenge is over, the organization has published demonstrating software showcasing how the challenge could have been solved. You can see the software here on its development platform. I would like to focus on one aspect here. The software was provided with a MyBinder service integration, allowing to run a containerized version in a Jupyter Notebook environment via one click. As the initialization takes some time, I already started in the background, and you can see here the Jupyter Notebook for the example analysis immediately. As you can see here, we need to download the example data. We will do that and fast forward to the step where we can run the notebook. The download has finished now and we can run the notebook step by step. This will take some time, so I will let you run it at your own convenience. With these two use cases, we have shown the current implementation of FAIR principles for the open science software in OSSR. Thanks for joining and stay tuned, there's more to come.